Okay, so what did you, so we multiply by 180 over pi. And the pi canceled out. What did you all do first? I'm just curious. You multiplied 7 times 180 first? Did anyone try to reduce before they multiply? You divided by who?
Yeah.
What did you divide by 4? And you got a decimal for the 180?
No, I divided.
What's 180 divided by 4? Because 4 doesn't go into 18. It seems like you all are going to do it totally different than first period. So I'm just going to, okay. It's usually easier to work with smaller numbers, okay? So one thing that I noticed that I can do is I can reduce these two numbers by 2. So what I did, okay, is I divided both of these numbers by 2, which made this 90 and it made this 4. So now I have negative 7 over 4 times 90 over 1, which is a little easier to work with than 7 times 8, 180. So what I just chose to do was reduce. I reduced first. So I cut that one, because you can always reduce. Okay, so I took the 180, cut that in half, took the 8, cut that in half. And now I'm going to multiply across, and I had negative 630 over 4. I also want to say the beauty of this question is that it's not just one way to do the question, to do it. Okay, so if you went about it a different way and you still get the right answer, that is okay. So then what I decided to do was take the 4. I didn't put the negative under there, but I know that my answer is going to be negative. So 4 goes into 6 one time. And then I'm going to subtract 6 minus 4, which gives me 2. Bring down the 3. How many times does 4 go into 23? 5 times. What's 5 times 4?
20.
And then we subtract. And I have a 3, and I'm going to bring down this 0. 4 goes into 30. How many times? 7. 4 times 7 is 28. And then that's a 2. So what I'm going to add here is a decimal point because I have a remainder. And I'm going to add one more 0. When I bring this 0 down, 4 goes into 25 times. So my answer would be negative 157.5. So if you took a different route and got there, we are still good. Yes, Trayana.
If I reduce the fraction again, because it's a fourth at the bottom, and I reduced it by like 2, and then I got the fraction version, is that right? 2?
So what did you do? You wrote it as a fraction, not as a decimal?
Yes.
So what did you write? Negative 157 over 2/4? Did you write it like 157 and a half?
No, I just divided the numerator and the denominator by 2. Does that make sense?
So you wrote it as 157 and then 2/4?
I think she said 315 over 2.
Yeah.
Oh, okay. So what you would have to do then is do this.
Okay, so still I have to get that.
You got to keep going.
Can you do the long division for 1260 divided by 8?
You want me to do that?
Because we didn't reduce. So
Oh, okay.
We had 1,200.
So 8 goes into 1260. That's what you got?
Yeah.
All right, so 8 goes into 12 one times. So 4. We're going to bring down the 6. How many times does 8 go into 46?
7.
Not 7. 5. I was asked to do this without reducing, so that's what I'm doing now.
8 times 5 is 3.
Okay. How many times does 8 go into 60? 7. 56. So we have a 4. And again, we're going to add that decimal 0. How many times does 8 go into 40?
You should pass out those papers that have all the times tables on it and have it on the face. You know what I'm talking about?
I should.
Not at all.
No, thank you.
I think about it because, you know, the multiplication is a problem. It's a problem. So, but I'm glad that you asked me to do that because you can see we got the exact same answer. So you get the same answer if you don't reduce first or if you do reduce first. All right, we got to kind of stay on track, guys, because we got a lot to cover. So next one, let's multiply this by 180 over pi. So I noticed that I can reduce by dividing both of those numbers by 10, which is going to make this a 1 and this a 18. So I have negative 3 pi over 1 times 18 over pi. Pi is going to cancel. So go ahead and multiply negative 3 times 18. Take a minute, see what you get. Hard. That's a rough class. Who got negative 54 degrees? All right, any questions about how to convert radians to degrees or degrees to radians? So the last thing we're going to cover in 6.1 is coterminal angles. So the prefix co means the same. So I'll give you a minute to copy this definition down. Bigger numbers, exactly. Yep. So you can have an angle that has the exact same terminal side with a different measure. Because I like to think of, essentially we're going to talk about this in a circle, and that's our next thing when we get into 6.2. But if I think of this as a track, there is more than one way to get to this specific point on the track, and you don't have to draw this illustration. Keeping in mind that we always start from here, I can rotate counterclockwise to get to this red dot. I can rotate clockwise to get to this point. I could also walk past that point, keep going, and do more than one lap and get to that point. Every time you do a lap around this track, we call that a rotation. Okay? And as long as we stand on the same spot, that is a coterminal angle. So essentially what we're doing is adding and subtracting a revolution. If it's in degrees, a full revolution is 360. But if it's in radians, a full revolution is 2 pi. So we're going to practice finding coterminal angles that are both positive and negative by adding and subtracting 360s if it's in degrees and adding and subtracting 2 pi if it's in radians. The homework assignment after today, Karma, you will be able to do the homework 1. We will have covered it all. So you can do that homework. It's not due until Friday. It's on Canvas. It's not out the book. It's on Canvas. The link is there. I believe it's set up for you to get 3 attempts So you can do it, you know, a couple of times. What else did I want to say? Oh, and it closes on, well, Monday is a holiday, so I need to make sure it doesn't close on Monday because we don't have school Monday. Okay, so let's get started. Let's look at example A. So we're going to find a positive and negative angle. So let's do the first two in degrees and the second two are in radians. Did somebody let Kimmy in? Thank you, Jasmine. Welcome. Welcome to Pre-Cal. My name is Miss Bryant.
My name's Kimmy.
Nice to meet you. There's a couple handouts on that desk for you to pick up. I just put it, yeah. Excuse me. So for 50 degrees, 50-degree angle, what quadrant would this fall in? Yep, the first. Good. So it would be about here. Okay. This is the terminal side, though. There is another way to get to that red, to that blue ray. Instead of rotating counterclockwise, we could go clockwise. So to figure out what this angle is that I highlighted in green, we would take 50 and we would subtract 360. Again, without a calculator. I know calculators are out on your desk, but you will not be allowed to use them on the test. So you're taking 50 degrees minus 360, which you can rewrite it this way. You can flip those numbers. Just know that your number, your answer is going to be negative. So we get 310 degrees. But it is going to be a negative 310 degrees. Now you're going to take 50 and add 360. And that's going to give you 410 degrees. So what I need for you to understand is that all three of these angles have the exact same terminal side. They would all land at this point on the track. And you don't have to stop by adding or subtracting it one time. Like, you can keep subtracting it. So I believe one of the questions on the first test asks you to name all of the angles that are coterminal. So you can continue to find additional angles by subtracting 360 again and adding 360 again. Okay, so it's not just one time. If I ask you for two negative angles, then you would have to subtract 360 from 310 again. Okay, let's go ahead and do question B. 165 would fall in quadrant 2. So we're going to take that 165. I want you to add 360 and subtract 360. So on the test, in the homework, when it asks you to find coterminal angles, I want you to add or subtract one full revolution. So 165 plus 360 without a calculator. And then 165. Oh, I put 365. Sorry, let me fix that. It's 360. So let's go ahead and do that. I can only add vertically. So I have to stack them. So I got a 5, 12, carry the 1. Who got 525? Okay, so 525 degrees. And then I need to subtract 360 minus 165. So we got to go next door, ask for one more. That's what my elementary teacher said. So then 10 minus 5 is 5. And then I have to do the same thing. Go next door, ask for one more. 15 minus 6 is 9. 1. Negative. That's a negative, though. All right, who had that for their 2 answers? So all 3 of these angles, again, they're coterminal. They all end at the same point on the track. They're coterminal angles. Now, for an angle that's in radians, though, we have to add it in radians. So we're not going to add it 360. We're going to add 2 pi. Okay, but what do we have to have in order to add fractions? A common denominator. So what do I have to do with this fraction? I need to multiply this by what to get a common denominator of 5? By 5. So that would be 8 pi over 5. And you're going to add 10 pi over 5 because 10 divided by 5 is 2. And then you're going to do the same thing with subtracting it. All right, go ahead and get your 2 coterminal angles. One positive, one is negative. Eight plus 10 is 18. And as you know, when you're adding fractions, we do not change our denominator. So it's not 18 over 10, it's 18 over 5. And then 8 minus 10 is what? Negative 2. All right, all 3 of these angles are the same. Go ahead and do part D by yourself. 5 pi over 4. Find a positive and a negative coterminal angle. So how would I rewrite 2 pi to have a common denominator of 4? So what would it be? 8 pi over 4. Good job. So when you add, you get 13 pi over 4. And when you subtract, you should get negative 3 pi over 4. All of these have the exact same terminal side. So it is possible to have an angle that's more than 360. All right, so that is the end of 6.1. Now we're going to transition into 6.2, which is the unit circle. Now, the second homework does come out of the book. I'm not going to pass out books, though, until tomorrow. So homework 2 comes out of the book. But what I want you all to do is try to get your first attempt at homework 1 in so you can kind of look at those questions. So homework 2 comes out the book. It's not due until January 17th. I might adjust that, but right now it's January 17th. I'm actually not here that day, so I may move it, but I'll let you all know. Okay, you don't have to write down these next couple slides. I just want to kind of give you a little bit of background about the unit circle. This is not necessarily anything you need to copy down. The unit circle essentially is the focus of the second semester of pre-cal for the first 2 chapters, okay? So what is the unit circle? So it's basically a circle with a radius of 1. So if you imagine that I'm drawing a circle on a coordinate plane and the radius is 1. Does this look familiar from geometry? X squared plus y squared equals r squared. There's a lot of geometry. You don't necessarily need to remember it, but this is where this formula comes from. To write an equation of a circle is x squared plus y squared equals the radius squared. And because the unit circle has a radius of 1, this is what this is based off of, okay? Who remembers this? Oh, we've talked about this on the way in today. Sine, cosine, tangent. All right, there's actually 6. Now, in geometry, they only talk about these 3. But there's 3 more. Cosecant, secant, and cotangent. A lot of times, it's kind of confusing because it says co and this says co. You would think that they go together, but they don't. Sine and cosecant are sisters. Cosine and secant are sisters. Tangent and cotangent are sisters. So that little strip of paper that I gave you, find a glue stick. There should be one around you if there's not one on your desk. In your notes, I just want you to write the trigonomic functions. And then glue that piece of paper down in your notebook. And then we're going to talk about this together. So you're not writing it down, just glue it down. Trayon, there's one on that desk. Oh, okay. Got you. Okay. And everybody got the little handout to glue it down? Okay, so we're going to talk about these 6 just a little bit. And then we're only going to fill out the first quadrant of the unit circle today. That's it. We're just going to talk about the first quadrant. There's 4 quadrants. Only going to talk about the first one. Truthfully, if you memorize the first quadrant, you can do the whole unit circle. Because it's just the same numbers repeated. It's a reflection. So we'll look at the first quadrant, see what patterns you notice. If you have a bag, glue stick, just throw it away. I do have some more on that table. Okay, so on the unit circle, you have coordinate points going around. You have X and Y. Okay. The sign on the unit circle, the sign of the angle is the y value. So I'm going to ask you, what is the sine of 30 degrees, for example? And you're going to give me the y value of that point. So sine is the y value. Cosine is the x value. The way I remember this, cosine, so all of the points around the unit circle, cosine, sine, I remember that because C comes before S in the alphabet. So the first number in our coordinate point is always cosine. And the second number is sine, okay? So that's these two. So these two, we don't need to do anything but look directly at our unit circle, okay? Tangent is a quotient property, meaning that we have to do division. So the reason why all of these four have this y cannot equal 0, x cannot equal 0, okay, is because these four can be undefined. There isn't a place on a unit circle where sine doesn't have an answer. Sine has an answer for everything. Cosine has an answer for everything. But it is possible for a tangent to be undefined. Okay, so to find tangent, we have to divide. And we're going to actually divide y by x. For cosecant, CSC means cosecant. We're going to take the reciprocal of sine. So that's why it says instead of just being y, it's 1 over y. And the same thing for secant. Secant is the reciprocal. And then cotangent, we divide. Okay, so let's just talk about where do these numbers come from, these little mystery numbers that we're getting ready to put in quadrant 1. And again, you don't need to write this down. They come from these, who remembers special right triangles from geometry? Okay, everything on the unit circle is based off the special right triangles. And if you did not understand it, it is okay because you don't really need to understand it. I just want you to know you don't need to understand special right triangles to do the unit circle. I just wanted you to know where these numbers come from. Okay, so now let's take our unit circle. If you have different colors, you can maybe, use different colors. If you don't, that's okay. I just, I'm a little extra sometimes. I like to use different colors, but you're going to fill out so many unit circles that you can redo this as many times as you want. All right, so let's go ahead and talk about quadrant 1. Let's get it. So the first thing I want to point out is, do you see these dashes that have degrees? We're going to fill in our degrees. We're only doing quadrant 1. All right, so this is 0 degrees. This is 30. This represents a 45-degree angle. This is 60. And what do you think this is right here? 90. All right, so next to it, we're going to go back in and write those angles in radians. And that's what this line is for, these lines. So 0 degrees in radians is still 0. Remember, we're essentially multiplying or dividing 30 by 180. 30 divided by 180 reduces to 1 over 6. And that's why this would be pi over 6. 45 degrees in radians is pi over 4. 60 degrees in radians is pi over 3 because 60 divided by 180 reduces to 1/3. What do you think 90 will be in radians? Pi over 2. We winning so far, y'all. We winning. So keeping in mind that the radius is 1. The easiest to fill out are the order pairs here and here. What do you think my order pair is going to be here? Not 0, 0. 1, 0. Because right here, x equals 1, y equals 0. So let's fill that in. So 1, 0 goes here. What about up here at the top? What do you think this is going to be? 0, 1. Okay, Miss Kimmy, nice to meet you. You seem to be doing quite well. Okay. For a 45-degree angle, that's an isosceles triangle. Does anybody remember what isosceles means? What does that mean for it to be isosceles? That both sides are what? Equal. Good. So for a 45-degree angle, sine and cosine are the same. Okay. They're actually both going to be, and I use this as a fraction bar. Root 2 over 2. I just like to pretend like that bar is a fraction bar. Some teachers write it like this. I don't like that. I like to use that as a fraction bar. So root 2 over 2. For pi over 6, root 3 over 2 comes first and 1/2 comes next. And for pi over 3, you're going to flip this coordinate. So from here to here, I want you to flip it. So that means the 1/2 comes next and the root 3 over 2. Okay? So if I were to ask you, what is the sine of 60 degrees without a calculator? What is the sine of 60 degrees? Root 3 over 2. And if you have a yellow calculator, if you type in the sine of 60 degrees, if you happen to have one near you, go ahead and type in sine of 60 degrees if you see one near you. Most calculators will say root 3 over 2.
How do you know it's root 3 over 2 and not 1/2?
What'd you say?
How do you know it's root 3 over 2 and not 1/2?
Okay, so going back to what we talked about, we have our coordinate. The first number is cosine, and the second number is sine. So all of these, so maybe I should have used different colors. As I might do different colors for 5th period. These numbers here are my cosines. And these numbers here are my sines. Okay, one more question. What if I ask you, what is the sine of 90 degrees? What's the sine of 90? 1. Okay. All right, so we're going to end there. But if you know this part, you can actually do the whole unit circle. And if you look at it, do you see that there is enough? I want you all to look at the screen one quick time. Do you see how there is a pattern? See how it's going 3? Let's only look at the numerators. 3, 2, 1, and then you go down 3, 2, 1. So it's a pattern to it. We're using 1, 2, and 3 over and over again. Okay. All right, go ahead and put it away, and tomorrow we'll continue on our unit circle.